Hello, good evening everyone. Good evening. I hope you're doing well. So let us start then. Yesterday we started the topic equivalent weight. Okay, so we started the normality. In normality, I covered one small point about equivalent weight. One type of questions I covered. Like normally in solutions we have three type of solutes. Sometime acid, base, or what? Acid, base, and you can say salt. So in case of acid, the n factor was what? Basicity. In case of bases, the n factor was acidity, and in case of salt, the n factor was total charge of cations or anions, right? So we covered that part. Now using the n factor, we can find what? Equivalent weight. How we can find? Given weight, you can say, sorry, the molar weight, you can say, molar weight of that compound divided by its n factor will give you equivalent weight. Okay, so this we have done, the basic thing we have done. Yes, beta Shakeen. Good evening, Praveen. Okay, so now we are coming to the basic of equivalent weight, and we'll cover step by step what type of questions can come in the topic equivalent weight, right? Okay, let us see then. Okay, we are starting from the basic. We can say from the start, like if you know, we take equivalent weight of hydrogen as 1, oxygen as 8, and chlorine how much? 35.5. Okay, you just keep this in mind, right? It also have a logic that why we take this. So I'm telling you here carefully. First of all, just for your reference, I'm telling you here, if I'm talking about the equivalent weight, I'm showing E. So if it comes about oxygen beta, if I'm talking about the equivalent weight of oxygen, so it is 8 gram, right? If we talk about the equivalent weight of, you can say, hydrogen, right? So it is 1 gram. And if I'm talking about the equivalent weight of chlorine, fine. So it is how much? 35.5 gram. Actually, equivalent weight of a substance is that weight which contains 1 mole of, you can say, charge, or you can say it is having 1 Faraday of charge. 1 more electrons carry how much charge? 96500 coulombs, and you can say 1 Faraday, you can say that, right? So basically for you, if I'm talking about simply, so these are 3 equivalent weights, first for oxygen, one for hydrogen, and 1 for chlorine. So definitions start from here only, from these references. They don't talk about so much about charge if you see NCERT or something else, right? Actually, if I say it is a weight of substance which will carry how much? You can say 1 Faraday of charge, or 1 more electrons, you can say. This way you can talk about, right? But you will not see this definition. We will see simple definition. We will see simple definition. What is the definition? They will say, for a metal or element or a substance, you can say. So for a metal or substance or element, anything you take, equivalent weight is that weight of substance which will combine with 8 gram of oxygen, or you can say 1 gram of hydrogen, or you can say 35.5 gram of chlorine. I'm saying once again, you imagine oxygen. I'm taking for reference oxygen. Oxygen's equivalent weight how much? 8 gram, right? If you remember this part, right? Equivalent weight of oxygen how much? 8 gram. So imagine this is my metal, some metal M. Imagine this metal's 20 gram is combining with the 8 gram oxygen. So whatever weight of this metal will combine with 8 gram of oxygen, I will call that weight as equivalent weight of that metal. Imagine it is some substance. Yes, it is some substance. Imagine if this substance 20 gram is combining with the 8 gram oxygen, so I will call this as the equivalent weight of the substance, right? So definition, you will see this one. You will not see the charge definition or more details. You will see this simple definition. That weight of substance, or sometime in case of, you can say, element, or sometime metal, whatever they are discussing. So that weight of substance which is combining with 8 gram of oxygen is what? Its equivalent weight. Are you clear about it? Okay, I'm writing this here. Okay, so try to understand. The simple definition they always write in form of these as reference, right? So I'm saying equivalent weight is that weight of substance, if I'm talking about substance, or you can say, or I can say element or metal, whatever I'm discussing, right? It is that weight of substance or metal or element, you can say, which combines, sometimes it combines, like which combines or displaces, which combines or displaces 8 gram of oxygen, which combine or displaces 8 gram of oxygen, or I can say, or you can say 1 gram of hydrogen, right? Or you can say 35.5 gram of chlorine. It's a good topic, okay? It is not an easy topic, so, and most of students make mistake here all the time. Okay, so this topic is little good. Students make mistake in this topic all the year, right? Throughout the year, so you have to be careful. Understand this topic very carefully. 90% students make mistake in this topic, so if you have any doubt, you ask at the time. Fine. I'm saying once again, it is that weight of substance which is combining with 8 gram of substance, or I can say 1 gram of 8 gram of oxygen, or I can say 1 gram of hydrogen, or 35.5 gram of chlorine, right? Clear? I'm saying once again, imagine I am taking some other substance, right? This is some substance. This substance 30 gram is combining with 8 gram oxygen. This substance 30 gram is combining with 8 gram oxygen. So I will call, okay, this is the equivalent weight of 30 gram is the equivalent weight of this substance, because it is combining with 8 gram of oxygen. Or I can say it's 30 gram will combine with 1 gram hydrogen or 35.5 gram chlorine, right? So these three we take as reference for our definitions. Clear, bacha? Right? Clear? So how they will ask question from here? How they will ask question from here? So I'm saying like equivalent weight of substance, or if I'm talking about a metal, maybe I'm talking about a metal for a specific question, right? So it will be that weight of substance which will combine with 8 gram of oxygen, or you can say 1 gram of hydrogen, or I will say how much? Or I will say 35.5 gram of chlorine. Okay, we will take many examples here, okay? Don't worry. I'm moving step by step. So carefully try to understand, then we will write a shortcut also. Okay, the first example I'm taking, imagine I'm saying, try to understand, I'm saying 100 gram of a metal, 100 gram of a metal combines with 40 gram of oxygen, right? 100 gram of a metal is combining with 40 gram of oxygen, right? The question is very simple. You can use unitary method, or I will tell you one more after this example. Yes, beta. The question is very simple. 100 gram of metal is combining with 40 gram of oxygen. So what is the equivalent weight of metal, they're asking. And you know that equivalent weight of metal will be that weight which will combine with 8 gram of oxygen. So use the unitary method and get the answer. Use the unitary method and get the answer, right? Very simple thing. Okay, if you see, I'm writing here, I'm saying 40 gram of oxygen is combining with beta what? Is combining with 8 gram of metal. Apply the unitary method. So 40 gram oxygen is combining with 8 gram of metal, right? Yes, Shakin, right answer beta. So unitary method I am applying just. So 1 gram of oxygen combined with how much? I can say 100 by 40 gram of metal. So similarly, I will say the 8 gram oxygen will combine with how much? 100 by 40 into 8. So if you solve this, what is coming? 20 gram metal. It's coming 20 gram metal, right? Yes, Mandeep, Zakir, Shakeen, right answer. So very simple. Apply unitary method, get the answer. 40 gram oxygen is combining with 100 gram metal. So 80 gram oxygen combined with 20 gram metal. And that is definition. Whatever amount of metal will combine with 8 gram oxygen will be our equivalent weight of metal, right? So I can say from here very easily that the equivalent weight of metal is how much? It's how much coming? 20 gram. Right? I hope we are clear up to now. Yes, Chetan, right answer. Right answer, right? Clear everyone? Okay, great. We can apply one more method here. We can apply one more method, right? What we will do? Okay, up to here, is it clear? I hope we are clear up to here. Fine. Okay, in a reaction beta, good. In a reaction, if I am writing, imagine this is a law of gram equivalence. I will discuss it in detail. Okay, after this topic of equivalent weight, you should know that when imagine A combine with B and makes C here, right? So I can say, even without balancing of the equation, I can say the gram equivalents of A will be equals to the gram equivalents of B will be and equals to what? Gram equivalent of C. Right? In the reaction here, if some reaction is going on A combined with B and give something C, I'm not balancing the reaction. I'm not using stoichiometry. I'm using the law of gram equivalence. Law of gram equivalence is saying here in this reaction that gram equivalence of A reacted with, if I'm taking here, it's 5 gram equivalent. So I will use 5 gram equivalents of B and it will make 5 gram equivalent of what? C also. So in the reaction, gram equivalents of everything will remain what? Same here. Clear? So similarly, if I say metal is combining with oxygen and making metal oxide, so gram equivalent of what? Metal will be equals to gram equivalent of oxygen and gram equivalent of what? Metal oxide. Imagine here some reaction going on. Imagine metal is reacting with oxygen here, right? And in the reaction making what? Metal oxide. So I can say in this reaction gram equivalents of metal will be equals to gram equivalent of what? Oxygen, right? And will be equals to what? Gram equivalents of what? Metal oxide. We call this law of gram equivalence. Try to understand. As I said, it's a good topic. It's not easy topic. So you have to be concentrated, right? If any issue is coming, we'll discuss it, right? So in this section, the gram equivalents of metal will be equals to gram equivalent of what? Oxygen, and will be equals to gram equivalent of metal oxide. Like in the previous question, I told this much amount of metal is combining with this much amount of oxygen. Okay, right? So, and it will make some amount of what? Metal oxide. So I can say very clearly that, and tell me one more thing. How we find the gram equivalent? How we find the gram equivalent beta? We find it how? We find weight divided by what? Equivalent weight. weight of metal, given weight of metal divided by equivalent weight of metal, right? How we find the gram equivalent of oxygen? This will find weight of oxygen given divided by equivalent weight of oxygen, right? Clear? So I can apply this method also. Here also I can go same way. I can say weight of metal oxide divided by the equivalent weight of metal oxide, right? This is law of gram equivalence. Okay, so by chance if you want to solve the previous questions like I gave in short way, you can use this shortcut. What I am saying, take this, use this concept, right? They gave weight of metal, you divided by equivalent weight of metal, which we normally found, equals to what? Weight of oxygen divided by equivalent weight of oxygen, or sometimes they give hydrogen divided by equivalent weight of hydrogen, or weight of chlorine divided by equivalent weight of chlorine. They can give question in any way. They can give question in form of oxygen, or they can give in form of chlorine or hydrogen. So you can use any of these, whatever is given, right? So we know this very well. Wm by Em here, fine. And here they will give this weight of oxygen, and this we know already, how much? 8. Weight of hydrogen they will give in the question, or you have to find, it is what? 1, or weight of chlorine divided by how much? It is 35.5. So this concept you can use better. You can use this concept for the previous type of questions, and I will give you some more questions. Whenever the question comes of equivalent weight, maybe based on oxygen, based on chlorine, or based on what? You can say hydrogen. So you have to use this concept. Clear? So I'm giving you 1 or 2 questions, so focus on this part, right? The previous question I gave you, just few minutes back I gave you. So look at the question. I said 100 gram metal, 100 gram metal was combining with what? Is combining with what? 40 gram of oxygen. Right? This was the question. I said 100 gram metal was combining with 40 gram of oxygen. And in the question I asked to find the Em. This was the question. Can you find this question using this concept? Very, very easy. How much metal? 100. Right? Divided by Em we have to find, right? It is the equivalent weight of metal, Em, equals to 40 gram of oxygen, right? How much weight of oxygen? 40 gram. What is the equivalent weight? 8. It is same thing exactly what we did previously. So what's coming with the Em from here? Em is coming from here, 100 into 80, 100 into 8 divided by 40, right? If you see what is coming, 20. Okay? So this type of questions you can solve from here very easily. Yes, 20 gram. Okay, I am giving you some more questions on this basis, and you will use this shortcut to get the answer. It is nothing different. It is exactly same thing which you did, just little in formula type of way I am giving. Otherwise, the question or concept is exactly same. So it is that weight of substance which combined with 8 gram oxygen, 1 gram hydrogen, and 35.5 gram of chlorine. Okay, Shakir, good. Right. Okay, fine. I'm giving you some more questions. Please try to solve this way. Okay? Easy questions. Fine, bacha. Okay, the next one I'm taking. Let's try. Some more questions, okay? Look at this. I'm saying here, okay. So the question is, imagine 80 gram of metal combines with what? 5 gram of hydrogen, right? So find Em. Exactly same question. This question they are giving in which form? They are giving beta in form of hydrogen. So nothing different. Exactly same one. Right? One more I am giving here. Right? Here I am writing, imagine 100 gram of metal is combining. They can write displacing also, right? Is combining with, if I'm saying 71 gram of chlorine, is combining with 71 gram of chlorine. So find EM. The most basic questions in our topic. The most basic, right? Mandeep, Chetan, Shakeen, how much coming? Okay, the first one they are saying 16 gram is coming. First one is 16 gram. Yes, everyone? This is 16 gram. Right? You can see, bache, what do we have here? Here we have the weight of metal. Weight of metal how much? 80 gram metal. 80 gram metal divided by the equivalent weight of metal, right? Here I am having 5 gram of hydrogen divided by how much? Equivalent weight of hydrogen how much? 1. So from here if you solve, bacha, the EM is coming how much? 16 gram. Very easy. Right? Very easy. Clear? What I used here, weight of metal divided by equivalent of metal equals to weight of hydrogen divided by equivalent of hydrogen. Fine? Good. Okay, the next one. Okay, next one you are saying 50 gram is coming. Right, Chetan? Let us see beta what we have here. So we are having here, it is again, I am using here equivalent of metal divided, I will say weight. So here we have weight of metal divided by equivalent of metal. This time they are asking chlorine. So weight of chlorine divided by equivalent weight of what? Chlorine, right? What is it? 100 gram metal divided by equivalent weight. We have to find EM, and here we have weight of chlorine how much? 71, and equivalent weight of chlorine how much? 35.5. So what's coming EM from here? If you solve this thing, it is coming what from here? 2. You solve it, how much coming? 50 gram. Great. Right only. Right. Great. Okay, easy questions. This type of easy questions. First type of question, right? Okay, the next one. This time, little be careful. Carefully give the answer. Imagine, I'm saying here, I'm saying 100 gram of metal oxide. 100 gram of metal oxide is containing 100 gram of metal oxide is containing 80 gram of oxygen, 80 gram of metal. 100 gram of metal oxide contains 80 gram of metal. So find equivalent weight of metal. This is the question. Carefully give the answer. Don't make mistake. 100 gram of metal oxide I am writing. This time I am writing 100 gram of metal oxide. Be careful. And it contains 80 gram of metal. So you can go in two ways. It's your choice. Just try. Give me answer. Just try to find the answer better. Right, fast. Be careful. This is metal oxide. This is not what? This is not metal only. I can solve this question in two ways. The first one is, if I say we are having 100 gram of metal oxide, right? They gave us we are having 100 gram of metal oxide. In this case, if you see what we have, 80 grams, so we have what? Metal. So definitely out of this 20 gram is what? 20 gram is oxygen. 20 gram is what? Oxygen. Fine, right? Now you can apply the method. In 100 gram metal oxide, 80 gram is metal and 20 gram what? Metal, oxygen, right? So So I can apply here that equivalent weight of metal divided by equivalent weight of metal equals to weight of oxygen divided by equivalent weight of oxygen, right? We can apply this one. What's coming from here? Weight of metal 80 divided by, I'm saying EM equals to how much? Weight of oxygen 20 divided by EO how much? 8. Okay? Yes, if you solve this thing from here, what's coming, beta? What's coming? If you solve this thing, what's coming? 32? Okay, fine. So you are saying EM coming 32 gram. EM is coming 32 gram. Fine. Good. Okay. Done. Right. On the same basis, okay, we can solve this question one more way. I will tell you after some time. But before that, we have to learn a simple concept. I will discuss what is that. I will discuss it with you. Okay. Now, the next part is, I'm talking about here, the next one. Same type of question I'm giving. This time I'm giving in terms of P or Q. Imagine I'm writing P gram of metal chloride. Imagine P gram of metal chloride contains Q gram of chlorine. Right? Find equivalent weight of metal. Exactly same. This time I gave in form of P and Q. Instead of writing 100 or 20 something like, I gave just P and Q. So please try. Fast. Right? This time I gave just P and Q, so be careful. P gram of metal chloride have how much of chlorine? Q gram. अरे बच्चा, right, good बच्चे. Okay. Yes, आता बेटा. Great. So just solve the question. Fast. So you can see here, I'm writing the next part. I'm saying here, I said we have P gram. We are having P gram of what? It is metal chloride. This metal chloride have some part of metal and some part of what? Chlorine. I said it is containing Q gram. It is containing Q gram chlorine, right? The next part if I say, so what is remaining, beta? Total P, Q is chlorine, so P minus Q is what? P minus Q gram is what? Metal, right? It contains P minus Q gram of metal, right? Yes, again, Mandeep, very good. Great. So what's coming here? If you look at this, what do we have? Again, I'm saying, I'm taking the equivalent weight, the weight of metal divided by equivalent weight of metal and divided by here weight of chlorine divided by equivalent weight of chlorine, right? What's coming from here? Weight of metal, P minus Q. P minus Q divided by EM. Chlorine how much, beta? It's Q divided by 35.5. Great. Easy. So we can find EM from here. The EM is coming, if you solve it, it's coming P minus Q into 35.5 and divided by how much? Q. This much gram is the equivalent weight of our metal. Fine. Great. I hope we are clear about this. So this type of question are very easy. Okay, done up to here. Okay, fine. Now try to understand one small topic in the same topic I'm discussing, a small point here, right? Be careful. We make mistake all the time about this point, so be careful about, right? So if you want to find, imagine I am finding the equivalent weight. I am finding the equivalent weight of metal oxide. Imagine I am finding the equivalent weight of metal oxide, right? I am finding the metal oxide equivalent weight. Even I don't know the formula, I don't know what is the formula, but I can say that the equivalent weight is what? It is equivalent weight of metal plus what? Equivalent weight of oxygen. I don't know what is the exact formula, but equivalent weight of metal oxide will always be equals to what? Equivalent weight of metal plus equivalent weight of oxygen. Getting my point? If you see, you can write here equivalent weight of metal chloride. Similarly, you will say it is the equivalent weight of metal plus equivalent weight of chlorine here. You can say chloride or Cl negative ion. Or in short, I am saying directly. You know this thing? It is what? How much it is? 8. It's how much? 35.5. Similarly, I can say the equivalent weight of metal hydride will be what? Will be equivalent weight of metal plus what? 1. Equivalent weight of hydrogen, or you can say hydride ion. Right? I don't know how many oxygens are present in the atom or in the formula. I don't know how many metal ions are present in the formula, but directly I can say that. This thing I cannot say about the molecular weight or molar weight. In molar weight, I need the formula. Then only I can give the molar weight value. Right? So carefully, imagine, I am taking one example. Then I will come to the next part. Imagine I have Al2O3. Imagine I have Al2O3. So I can say clearly that the equivalent weight, right? The equivalent weight of Al2O3 will be what? I am writing Al2O3. It will be very easy to say. It is the equivalent weight of what? Aluminium. And equals to what? Equivalent weight of oxygen or oxide ion. So I will not write here, I will not multiply here by 2, or I will not multiply by here 3. I will just add the equivalent weight of both the ions. But in case of molar weight, when I find molar weight or molecular weight, you can say I have to multiply by 2 or 3 here. Okay? Clear? Look at this one. If I want to find its molecular weight, if I want to find the molecular weight, okay, so what I will do? I will do 2 into the molecular weight of aluminium here and plus of what? 3 into molecular weight of oxygen. Right? But in this case, I will not multiply by the coefficient. Just I will add. This is special thing here, right? Getting my point? What I am trying to say? Clear, beta? You can say here also 3 plus and 2 minus, right? So in case of equivalent weight, you will not multiply by coefficient. It is not required. Just add equivalent weight of metal plus equivalent weight of oxygen. This is a very important point where students make mistake all the time. So be careful about it. Be careful about it, right? Are we clear about this? Fine. Clear? Okay, fine. Now imagine I am writing one more thing. Imagine here I want to find equivalent weight of metal sulfate. Imagine metal sulfate. Even I don't know the exact formula, but I can say it is what? Equivalent of metal plus equivalent weight of what? Sulfate. Again, coefficients will not come in finding the equivalent weight, right? We will clarify it now in next point also. I will take more examples to clarify. The main thing I am explaining here, the coefficient will not come. The coefficient will not come. That is the main thing. I am taking one example. We will try to understand it. Okay, bache? I am taking one example and we will try to understand. Okay, done? Fine. Look at this. I am giving one question. The question is, look at this. They are saying equivalent weight of metal hydride. I am saying metal hydride is you can say 13 gram. So please find, the question is find equivalent weight of metal oxide and find the equivalent weight beta of metal chloride. Make it fast. They give the equivalent of metal hydride and they're asking for metal oxide and metal chloride. Make it fast. You know what it is, na? You know what is it? From here you can find EM. From here you can find EM, and using the EM you can find these things. Try what you try. Think about it. Look at the previous page, what we wrote there. Here's the concept. Yes. Okay, fine. Look at this. What I said just now, on the previous slide, what we wrote, beta, I said very clearly that equivalent weight of metal hydride is what? What they gave the value? 13. We know this, it is equals to equivalent weight of metal plus equivalent weight of hydride. I can say that what? 1. We have seen this. From here I can say the EM value, yes, but a very good answer. The EM value is coming from here. It's coming 12 gram. The EM value is coming 12 gram. Fine? Right? It is 13. EM coming what from here? 12. Now from here I can say very clearly, very easily that the equivalent of metal oxide is what? EM plus how much? For oxygen how much? 8. It is 12 plus 8. How much coming? 20 gram. Very good. Right? And the next one is, it is EM for chlorine. EM plus how much? 35.5. So what's coming from here? EM you know 12 plus 35.5 for chloride. So how much coming from here? 47.5 gram. It's coming 47.5 gram. Fine? Got the point? Yes, beta. Are we clear about this? Good. A same question, please, once more. Okay. One more I am giving, beta. They are saying the equivalent weight of metal chloride. The equivalent weight of metal chloride is given as, I am saying, imagine they gave 55.5 gram. So please give me the answer for the equivalent weight of metal oxide. Fast. Even we don't know the formula, but we know the formula of equivalent weight. Very easy. Give me answer. What's coming, beta? What is coming? Okay. Manideep, 28 is coming. Okay, Shakeen. Fine. Great. So we know this value, na? We know this very much. We know how to write this. It is equals to equivalent weight of metal plus what? Chloride, we know very well, 35.5. We can find EM from here. What is coming, beta? From here, what is EM coming? If you find EM coming how much? 20. EM is coming 20. Now, for metal oxide, we know that it is what? EM plus 8 for metal oxide. EM how much? 20 plus oxygen how much? 8, so 28 gram. It's coming 28 gram. Fine. Okay, right? Now, we have seen how to find the equivalent weight of acid, base, or you can say salt using the N factor, right? Imagine if some ions comes. Imagine if some ions come, beta. For ions, what is the N factor? For ions, beta, what is the N factor? For ions, N factor is what? Charge. For ions, if you want to find their equivalent weight or their N factor, you have to see their charge only. Okay? So carefully give the answer for this question. Ions I am talking about. So imagine I am having here aluminium plus 3. What is its N factor and find its equivalent weight? Imagine I am taking here sulfur 2 negative. Find its equivalent weight here. I am taking here sulfate ion. Okay, fine for this one. and carbonate ion. Tell me their equivalent weight and then tell me their N factor first of all and then tell me their equivalent weight. Charges are their N factor. We have done acid, base and salts. If any ion comes separately, their charges are their N factor and you can find the equivalent weight using their N factor, right? Yes, beta, tell me fast. What is its N factor? Its N factor is what? See beta, very easy. Its N factor how much here? 2. Its N factor how much? 2 here. Charge is 2 na? Its N factor also how much? 2. Clear? So find me its equivalent weight beta. If I ask you what is the equivalent weight of aluminium here, tell me what is coming. How much? I can say molar mass 27 divided by 3. 9 is coming, right? 9. Similarly, if you want to find the equivalent of sulfide ion here, what's coming? 32 for sulfur divided by 2. How much coming? 16 gram. Similarly, if I want to find the equivalent weight of sulfate ion here, how much? It's coming EM. What is the mass coming sulfate ion? Okay, great. What's coming the mass beta for sulfate ion? 96 coming? Okay, 96 divided by how much? 2. So 48 gram. Fine. And for the carbonate ion, tell me what is coming for carbonate ion? 60 is the molar mass. 60 is the molar mass, right? And divided by 2. So how much coming? 30. Very good. Yes, everyone. So if any ion is there, you can find its equivalent weight very easily, right? By dividing its charge. Charge is its N factor, right? So please tell me this also. If I am giving you one more, imagine OH minus, and I am giving you here one more here. It's PO43 minus. Tell me for these two better. N factor is very much clear. You can see charge, and then tell me equivalent weight. I will use these in the next question. Yes. Fast, fast. How much coming? In case of OH minus beta, what is the N factor? N factor is what? 1. N factor is 1. You can find the equivalent weight of OH minus hydroxide ion. How much is that? How much? 16 plus 1. How much? 16 plus 1? 17. 17 is the molar mass divided by 1. So 17 gram coming, right? And for phosphate ion, the N factor how much? 3. What is the equivalent weight of phosphate? It's PO43 minus. What is the molar mass coming? What is the molar mass coming, beta? What is the molar mass of phosphate? It is 31, oxygen 64, right? 31 plus 64. 64 plus 31, how much coming? 95. 95 by 3, you can say 95 by 3. Great. Okay. Now using this concept, you have to tell me the equivalent weight of the next question. Now you know how to find the equivalent weight of ions. Okay, clear? Yes, 95 is the equivalent weight. Sorry, molar weight divided by 3. Whatever coming almost. 30 point something or 31 point something, right? Now, look at this. The question is, if equivalent weight of metal oxide, I'm saying, imagine is coming 40 gram. So find equivalent weight of metal, I'm saying metal carbonate. It's metal carbonate, right? And I'm asking you equivalent weight of what? Metal sulfate. And similarly, I'm asking equivalent weight of what? metal hydroxide, right? Just for your help little bit, equivalent weight of metal carbonate is what? It is Em plus what? E of carbonate. What is this? It's Em plus E of sulfate. The main thing I am trying to say here, there is no need of coefficient. I don't know the formula, but still I can find the equivalent weights, right? It is what? Em plus E of hydroxide ion, OH negative. Yes, fast. Okay. For phosphate, you are saying 31.67 coming, right? For phosphate, you are saying 31.67 coming. Okay, that's good, right? ऐसे बेटा make it fast. Okay, Mandeep. Fast. Right. Okay. So from here you can see, bacha, what is coming? From here I can say it is equals to Em plus oxide ion, right? Oxide how much? 8. Oxide is 8. So Em is very much clear. But what is Em coming? Em coming how much? 32 gram. Em is coming 32 gram. Fine, right? Now we know very well that how to find this. I got the Em value. I got the Em. It's 32. For carbonate, just now we found, right? For carbonate, just now we have we found that in the previous question. What was that? For carbonate, it was coming how much? I think it was 30 coming, right? So 62 gram. Fine. Here, beta, 32 here. For sulfate, how much was coming? 48 was coming, right? So 48 coming. So I think it is 80 gram coming, right? And here we have for metal how much? Metal is how much, beta? Metal 32 and hydroxide how much? 17. Just now we did. So what's coming if you add it? 49. Right? Okay. So you said 62, 80 and 49. Okay, beta. Very good. Great. I hope we are clear about this. Fine. Okay, so now we are clear about this type of questions. First type of question we have seen about the definition of equivalent weight. Fine, bache. We have seen one type already in yesterday class for acid, base, salt, and now we have seen for ions also. Okay, right. And now we are coming for the questions next type, which is based on the reaction. Right? Which is based on the reaction. Okay, great. So for those type of questions, you should know a little bit about the oxidation state. If question comes based on the reactions, in case in given reaction they will ask find the N factor of this substance. So in those questions you have to find the oxidation state of those elements which are changing the oxidation state, right? So for those questions I need little bit about the oxidation state. So I am asking a small question. If you are clear about this topic, just try to find oxidation state of these given elements I am asking, right? So please try some of this question. I will tell you. Okay. So find oxidation state, or you can say oxidation number. Find oxidation state of underlying atom. Then I'll come to the next point. right? Please, easy I am giving, just basic I need. In KMnO4, please try for Mn. Next I am taking beta here. Imagine I am giving you K2Cr2O7. The most important things I am giving only. Please find for Cr here. Here I am writing NaClO3. NaClO3. Find for Cl here. And if I am saying the next one, I am giving you some ion. Nitrate ion, NO3 negative. Just basic thing I am writing here. If you know how to find the oxidation state for this atom, right? The basic thing I am telling just one thing. In case of neutral molecules, sum of the oxidation state of all the atoms will be equal to what? 0. Whereas in case of ions, the sum of the oxidation state of all the atoms will be equal to the charge present on the molecular ion, right? So apply the concept, try to get the answer. There's few of these, right? Yes. I am finding for which one? Mn. I know for potassium is alkali metal. For alkali metal it is always fixed value. Which one? +1. It is +1, it is X. Oxygen how much? -2. So I am applying the formula here. Potassium how much? 1. Plus manganese how much? X. Here how much beta oxygen? 4 into -2 equals to how much coming? 0. And what is coming X from here? X coming beta how much? +7. Yes, X coming +7. Very good beta. Right answer. The next one is K2Cr2O7. For potassium I am saying 2 into 1. For potassium 2 into 1. For chromium how much? 2 into X. Right? Because there are 2 chromium. Na? Be careful. In K2Cr2O7 I am having 2 chromium atoms. So I will take 2X. Yes beta, very good. So here I am taking 7 into -2 equals to how much coming? 0. So X coming from here, if you want finding, it is coming +6. Very good. Okay. The next thing is NaClO3. NaClO3, sodium how much? 1. Alkali metal in their compounds always show +1. Alkaline earth metal in their compound always show which one? +2, right? So here +1 for sodium, X for chlorine, and here we have 3 into -2 equals to 0. So X coming how much? +5. X coming +5, right? +5. And this time nitrate ion. Nitrate ion is a molecular ion. It's not neutral thing. So be careful about it. Nitrogen is how much? X. Oxygen how much? 3. And here how much? -2. So X plus 3 of -2 equals to how much? -1 here. So what is coming X here? X coming +5. X coming +5. Yes beta. X coming +5. Right? I hope we are clear. I hope we are clear about this. Yes bache? Good. Okay, this is it. How to find the oxidation state of the underlying atom. To find this oxidation state, I need the oxidation state of remaining elements. The remaining I know already. Oxygen 99.9% how much? -2. And sodium always what? +1. Alkali metal always +1. Alkaline earth metal always +2. In their compounds I am saying, right? Oxygen what? -2. Hydrogen what? +1. Very rarely sometime -1. Otherwise it is fixed values. Okay? Okay, same question I am asking, 1 or 2 more for practice, and then we will start the next topic. Fine, bacha? Try these. Try this one. If I am talking about, imagine we have PO4, 3 negative, find for phosphorus beta. The next one I am saying here, we are having CrO4, 2 negative, find here. Okay? And here we have the most common here is H2SO4. Here we have S2, so 5. Be careful about this special point. And we have here S2, S2, O8. Right? Here we have to find for phosphorus, here find for chromium, here find for sulfur, here for sulfur, here for sulfur. Please tell me. Right. And one more I am asking. Tell me for this also. If I am writing a neutral atom, like I am writing copper, just copper, right? Or I am just writing some others like Cl2. So find for chlorine also. In this case, find for copper. In this case, find for chlorine. It's a homoatomic molecule and it's a normal atom, just simple atom, without any charge. Without any charge, I am saying. Okay, fine. Yes, beta. Right? In this case, if you see, bache, in this case, we are finding for phosphorus. Imagine phosphorus as what? X. Oxygen how much? 4 into what? -2. Equals to how much coming? -3. Right? So what's coming? X from here? X from here is coming how much, beta? +5. X coming +5. Very good. Yes, right. Now if you go for this one, how much for chromium? X is given 4 into -2 equals to how much coming? -2. If you solve this, X coming with how much from here? Yes, you can write it +6 coming. Very good. Yes, if you go for sulfuric acid, yes, beta, for hydrogen 2 into 1, sulfur how much? X 4 into -2. For oxygen equals to 0 coming, right? That's why X coming how much? +6. Okay. Now find for the S2SO5. This is very, very important. Give it a star mark. Here star mark, here star mark. These 1 or 2 are very, very important. These 1 or 2 are very, very important, right? Okay, Mandeep, be careful about one thing. Sulfur can never have oxygen state more than +6. You should know about it. Oxygen can never, sulfur. Sulfur can never show oxygen state more than +6. So be careful about it. Actually, this is a peroxide. Normally, you are doing what? You are applying a formula, simply 2 into 1. Sulfur, you are writing X. And you are saying 5 into what? -2 equals to 0, right? And yes, from here, if you find beta, what's coming? What's coming from here? If you try to find from here, sulfur coming how much? 8 coming? It's coming +8, right? But be careful, this is wrong. I will tell you why this is wrong. This is wrong. I will tell you why. Okay? Don't worry about it. The next thing is, if similarly you go for this one, you're going for this one, you will see 2 into 1. Here we have 2x, and here we have 8 into -2. Fine, equals to 0. And if you solve, I think x coming what? +7. +7 coming. Again, it is wrong. Sulfur can never show more than +6. Sulfur can never show more than +6 oxygen state. Yes. Why we'll discuss about, don't worry. Formula is giving this only. Formula is giving you here +8, here +7. But why these are wrong, we'll discuss about it, don't worry. Here how much coming? Yes, it is neutral atom. It is just a neutral atom. Yes, neutral atom will always have how much? 0. Here to how much always? 0. And here also if you see beta, imagine for chlorine how much? X. So 2 into x equals to how much? 0. X coming 0. So in this homoatomic molecule, chlorine is what? 0. And copper also how much? 0. Okay, so we should know about it. Yes, yes. So why it is happening like this? We'll see about it. Yes, basically you are good. You know about this. You know how to find the oxygen state. Because for our next topic, for next type of questions of equivalent weight, you should know how to find the oxidation state. Are we clear about this? These two I will discuss. These two I will discuss how and why it is happening. Why formula is giving us wrong answer. Okay, fine. Okay, you know what is peroxide? Actually, oxygen normally or always you can I will say 99.9% cases always show which one? -2. But some exceptions exist. Oxygen show -2, you will see. Oxygen normally show -2, right? You can say normal oxide, simple oxide, or you can say normal oxide. But sometime oxygen show oxygen state how much? -1. Sometime oxygen show oxygen state of -1. What do we call them? Tell me. Sometime oxygen show -1. What do we call them, Eta? What do we call these oxides? Tell me. Yes, Mandeep. Yes, Shagin. What do we call them? We call them peroxides. When oxygen show which one? -1. We call it peroxides, right? And sometime oxygen show -1/2 oxygen state also. Sometime oxygen show -1/2 also. Oxidation state. We call them superoxides, right? We call them superoxides. These are superoxides, right? Yes, peroxide and superoxide. You can see this. So these two questions, why answer is coming wrong? Because in the formula you took every oxygen what? -2. In the formula you took every oxygen beta as what? -2. Because we were thinking that every oxygen is simple oxygen or simple oxide, but we don't know actually out of these some of oxygen are what? Not simple oxide. What is it? Like peroxide is there, right? And here also we took as -2. But some oxygen have oxygen-oxygen bond and they are peroxides. That's why the formula is giving us wrong answer, doing some mistake. Okay? If you look at the formula, look at the structure, sorry. For this, we need structures actually. If you draw the S2SO5, if you go for S2SO5, you will see the structure look like this one. S double bond O, S double bond O. It is OH beta here, and here we have O, O, and H. Okay. Actually, in the structure, if you can see, in the structure we have OO linkage. That OO linkage is known as what? That is known as your peroxide linkage. We call it peroxide linkage. So actually, if you go in detail, you will see this oxygen is okay, -2. This oxygen -2. This oxygen -2. But this oxygen not -2, but how much? -1. This oxygen also how much? -1. But in the formula you have seen, we put every oxygen as what? -2. But in the structure is telling us that these two oxygen are not -2. These are what? -1. That's why formula gave us wrong answer. So a simple shortcut is, if by the formula, by chance, you are getting sulfur oxygen state more than +6, that means you are doing mistake. Answer should be +6 only, because sulfur can never show more than +6. So by the formula, by chance if you get +7 or +8, you just stick which answer? +6. It can never be more than +6, right? Similarly here, beta, if I look at the other one, if I look at this one, you see, I'm talking about S2OH, right? In this case also you have peroxide linkage. The formula is like this one. We are having here OH, here sulfur, linkage here, right? It is also having peroxide linkage. It is also having beta OO linkage here, OO. Right? That's why this also, these two oxygens are not -2. These two oxygens are what? This oxygen is -1. This oxygen also what? -1. But in the formula you have seen, in the formula you put only what? -2. You took all 8 oxygens as -2. But out of the 8 oxygens, 2 are what? -1. That's why formula gave us wrong answer. I hope you are clear about this. Why it is happening? Because all oxygen are not normal oxide or not -2 oxygen state. Some of these are -1. Yes, beta. I think we are clear about this. Okay. Now we will start the next type of equivalent weight questions in next class, because time is very less only. So I am giving you one or two small question. Tell me which one is oxide, which one is superoxide, which one is peroxide out of the following. Okay. Okay, fine. Look what say. Identify which one is simple oxide, which one is peroxide, and which one is superoxide. This way. Okay. Remember, alkali metal always show +1 oxygen state in the compound. So in this molecule, you have to find for oxygen. In this given question, find for oxygen here. What is oxygen state? For oxygen, find for oxygen. Alkali metal to always show which one? Alkali metal always show which one? +1. So find for oxygen in this given molecules. Find fast. One more I am giving here. Writing here it is BaO2. Tell me which of these is peroxide, which of these is superoxide, and which of these is like a normal oxide. Simple oxide, peroxide, normal oxide, right? Alkali metal always show +1, no exception. Alkaline metal always show +2, no exception. Yes, Mandeep, right answer. Yes, Shagin beta. Okay, great. So if we solve this one, what's coming for sodium? 2 into 1 for sodium, x for oxygen equals to 0. So x coming how much? X coming simply -2, right? X coming -2. In this case, we have to find for oxygen. 2 into 1 for potassium, 2 into x for oxygen equals to 0. So from here x coming how much? -1. Okay. KO2 beta. Potassium 1. Oxygen how much? 2 into how much? X equals to 0. So x coming how much? X coming from here how much? You can say -1/2, right? It's coming -1/2. Great. Yes, 1 here, 2x here. So okay, fine. -1/2 coming. Now in this case, if you check, bacha, Ba how much? Ba is alkaline earth metal. So 2 here. 2 into x for oxygen equals to how much? 0. X coming how much? -1. Okay, so very easy now to find. This is our normal oxide, right? This is our normal oxide, simple oxide. Oxygen but -1. This is your peroxide. Oxygen how much? -1/2. It is what? It is your superoxide, right? And here oxygen -1. So it is what? Peroxide. Yes, beta, fine. I hope we are clear about this. Okay. So this is it for today. The next type of questions on equivalent weight we will see in the next class. Okay, bacha. Bye then. See you. See you on Monday. Okay, bacha. Bye.